program on innovative applications and ethical consideration of artificial intelligence in modern research.
Hello everyone, I'm Swarika and we're excited to continue this journey of knowledge and innovation with you. Today, we'll explore crucial aspects of data storage and cyber resilience as well as advancements in computer architecture for AI and ML applications.
The first session of the evening is titled Data Storage with Cyber Resilience. This session will cover strategies for building robust and secure data storage systems that can withstand modern cyber threats while supporting the demands of AI and other advanced technologies.
We are honored to have Mr. Sunil Kumar Mishra, Senior Pre-sales Solution Engineer at NetApp India, as our speaker. With over 16 years of experience, Mr. Mishra has been at the forefront of implementing innovative and effective data storage solutions in the ever-evolving tech industry.
Thank you, Mr. Mishra, for being here with us today. We are eager to learn from your expertise. Over to you, sir.
Thank you. Thank you for welcoming. And I hope you guys can hear me, everyone.
Yes, sir.
Is it clear?
Yes, sir, it's clear.
Okay. Okay. So I'll share my screen. Let me know once you all can see the screen.
Yes, sir, it's visible.
Okay. Let me know when we are ready and we can start. We can start?
Yes, sir, I
Yes, sir.
think we can begin.
Okay. Yeah, again, good evening, everyone. And thank you for inviting me to talk about storage technology and how it is affecting AI and applications around AI and machine learning, right? So a little bit in the introduction about myself. My name is Sunil Mishra, as already said. Currently, I'm based in Bangalore and associated with NetApp as a senior pre-sales solution architect. I have 15 plus years of experience, in solutioning, and I've done solutioning data, made data infrastructure solutions for large customers, large government customers, banking and financial institutions, ITS organizations across. Overall, I have 70 plus years of experience. Initial years, I have done also implementation of Unix environments. I have experience in working with organizations like Dell, EMC, Hitachi Data Systems. Now it is Hitachi Vantara HCL Technologies, and currently with NetApp. Yeah, this is about me. Uh, so I will. This presentation, I thought when this requirement came up in terms of how do I take this ahead, and what my understanding is many people don't know the role of storage. Uh, Storage being the most critical part of a data center or any environment, whether you're building AI or any kind of application, right? So many people don't know how do we go ahead and choosing a right storage for my needs, right? So I built a solution. That's why I've named the slide Storage 101, where I'll discuss about multiple types of storage, what all the storage are currently available in the market. Obviously, I'm working as a NetApp, so you will see some NetApp flavors. But yeah, you can ask me questions. I am not sure how the question answered, whether we should take it at end, or I'm okay with even if you stop me and ask me questions in between my slides as well, right?
I
So I'll
mean, there will be an option to the participants. If they raise their hand, we will unmute them. So it can be done either way.
Sure, sure. So based on your understanding, you can ask me question, and later also you can write me a mail. I'm available for you, right? And storage being a most critical part of it. Now, since we are talking about AI, this one slide I got, and how the AI is getting adopted across industries. This is one research from Froster where they are talking about 50% of enterprise AI initiative will boost productivity and creativity by problem solving. So that number is huge, right? And the 60% of worker will use their own AI platform, some in some other ways to increase their productivity, right? Data analysis or insights. And within 3 years, because of AI, the global average customer experience is going to be improving first time. That's what we are seeing, because we are adopting AI, how we can improve the customer, and customer being the centric for any kind of applications which we plan and develop. Now, what are the top reasons of failing? 85% of AI project fails, right? People start, companies start, and they fail. Why I have put data access as bold in a color is data access being number one important thing. So what you understand in terms of you know how the data pipelines are built. So why we call it data pipeline, because we are accessing some kind of data. Now think about a scenario where in an enterprise or in an organization, your data is scattered across multiple silos. You have a lot of data, but you don't know where it is. Some data might be in a data center, server, storage. Some might be on a computer hard drive. Some might be on cloud, right? Now, when you're building artificial intelligence and machine learning, how do we bring all this data together to get better analytics, right? And that's what is not happening. People are not understanding that, and they're building these applications for separate use cases, right? If they build a single data lake and build pipeline on top of it, it will be much more beneficial for organizations building AI, right? So now, this is one slide. Most of them you will be aware, how the infrastructure actually is stacked up within an environment. So you have application at top here, which end users will be accessing. They are developing the application for AI, EDA, analytics, Elasticsearch, OLTP, or any kind of applications, right? Below that, we have our computes which are running, and then we have a protocols by which you are accessing the data. So different application will access using different protocols. Some will access while using file protocols like NFS, CIFS, SMB. Some will use block protocol because they are already structured, and some will use object because they are built cloud native, and cloud native generally use S3 as a protocol, and that's how they are doing. And some are archival, and suppose somebody is building data lake, probably those kind of use cases for object storage, because object storage is one area which is picking up very big in AI and machine learning field. And then comes the storage. Now, storage also different type. You have different media in terms of supporting whether I'm using for a backup. Do I need a speed or do I need a capacity? In some applications, you need balance between capacity and speed, but price also a challenge. And there are some which are very critical application where, like banking, right? Or you're building an AI chatbot for enterprise, where for a bank, right? Now, those applications will not worry about money, but they will need performance, low latency for any of their requirements. So that kind of and then the deployment types. It can be on-prem. Many of the organizations, because of stricter restrictions on data regulations, they keep on-prem, or they think keeping on-prem, they already have IT name is a cheaper option, or they build a private cloud using VMware or Red Hat or any of the open source technologies, or they go to a cloud, which is any of the clouds like AWS, GCP, Azure. So all these are basic layer of infrastructure. Below that, above that is protocols, and then by using those protocols, all application access your data, and then you have operating system and platform, which I have already mentioned, right? Now, major categories of data. There might be chances that many of you know, but since I have kept the name as 101, I wanted to cover basic things and then move, right? And then probably we'll take it up from here. So what are the major categories of data? There are two types of data when we talk about structured and unstructured. Structured data is already has a predefined architecture. It is controlled by application. When it is written at a storage, application controls it. It knows where and how, what is the format of data. Latency affects this significantly. So you should have low latency when it comes to structured. Examples are any of the databases like Oracle, any RDBMS database, SQL. These are all structured data because the application manages data. It is not like, storage is not putting any kind of a separate file system to manage it. It just gives the blocks a raw storage, and the application or these applications which are already have a lot of data, but in a structured format where they are managing it. For this, we prefer block storage. Block storage means a raw storage which doesn't have any file system on top of it. It just gives you capacity to host, and the host stores the data. Host means servers, right? Then the biggest part is unstructured data. Structured data databases will not be so big, always. So what is biggest part of data? 85% data almost is unstructured. 85 to 90% of data in an organization is unstructured. You can see any of the data center, any of large institutions, banks, or any of the applications, where the AI is building. Also, they are leveraging more of unstructured data. The data originating from whether video camera, sensors, telematics data, or any kind of data which is not structured, we call it as unstructured. They don't have any predefined architecture, so they need some kind of architecture, and they need some kind of file system to support, mostly PDF files, video files. So those are called unstructured data. File and object storage are preferred storage. File and object storage are preferred storage for storing unstructured data. Now, why in unstructured data, what is file and or object? Why we should store in file and why we should store in object? There is specific use cases for both. Files have a simple protocol and has been there for a very long time. Most of the applications, older legacy applications or even newer applications, use file for accessing the unstructured data. The file protocols are NFS CIFS SMB or NFS RDMA, which is NFS RDMA, which is mostly used for GPU based, with GPU based. If there is any NVIDIA GPU based implementation which is happening and which needs more performance, low of overhead from NFS. NFS RDMA is the protocol which you use. The applications are more compatible. This is more advanced, I should say, file, but there is a limitation because every file system has a limitation of storing data. Now, since the data is growing and coming from, so think about a scenario. I want to build a data lake from data coming from video sensors, from other telematic sensors or some motion sensors. Real time, I want to access data when it is, if it is ADAS. In those scenarios, the data quantity is huge, right? So file system is not built for storing that huge data. In those scenarios, mostly the data, the objects at the underlying object storage will be used. So basically, if you see Amazon S3 is a object storage, underlying Blob is object storage. Just to give you an example, in a NetApp we call it storage grid is object storage. Hitachi has HCP, Hitachi Content Platform object storage. Dell has something called the Elastic Cloud Solution, which is object storage. So these are object storage from different vendors which are offered. Object storage can be on-prem, cloud, or can be hybrid, right? So we support hybrid. We are one of the NetApp is one of the vendor which supports hybrid as a technology. Object storage mostly get accessed by APIs, S3 API. The call is always get put, and Swift API now it is legacy. Mostly it is S3 API what is getting used in in the object storage requirement. Now, what is now block storage? Mostly block storage is accessed from host directly, as I told you, with physical addressing, right? There is nothing, no file system underlying which is built. Applications leverage their own file system to access the block storage, and this is mostly the block storage protocols as iSCSI, which is on. If you use Ethernet as a technology, it is iSCSI protocol. Most of the time it is now latest is NVMe because protocol has changed. NVMe over FC and NVMe over TCP are the latest protocol for accessing block storage. Any questions till now, or I can proceed? So I understand there is no question. I can proceed. Storage designing criteria. So what you should understand, what do you think while designing a storage? What should come in your mind? So you are talking about AI, but the most critical part of infrastructure. So think about a data center. You have servers, thousands of servers, or suppose tens of servers, and you have a storage. Storage will be single where your data is getting stored. Now, if your two server fails, your applications are still running, and especially in virtualized environment, probably with a little bit of lower, I should say, in terms of performance, but your applications will still keep running if they are cluster aware, and there should not be an issue. You can change your server anytime. But suppose something goes wrong with your storage, if you lose your data, so data is the most critical part of any project in AI, ML, or any enterprise solutions or anything you can think about it. You can think about your laptop data. You lose your laptop data hard drive. You lose your laptop, that is fine. But if your data is safe on cloud, you'll be okay. Chalo, I have lost a laptop. I'll buy a new laptop. I get my data. But losing a data is very, very critical. Think about enterprises who are running on data, right? So data is one kind of lifeblood for any organization. So that's why I told storage designing is most critical thing in terms of security, performance. Each and every aspect of storage designing matters for any project to be successful. IT project, right? Now, what are the criteria for selecting a storage? Where to store the data? So first we have to decide whether I have my current own DC. I'll buy a storage from vendors and I'll manage it myself. I'll deploy it at my data center and I'll use it. I'll manage it myself with the help of OEM support, or I'll deploy at a colo location, any of the third party like net entity or any of the third parties which give hosting services to customer. Edge location, where I have a storage at core, and because there are multiple applications which are running for my edge location, so I need a storage there. Public cloud, any of AWS, GCP, Google, IBM, those public clouds you want to deploy there, or a hybrid cloud wherein I choose my application. I have 100 application, 80 application I'll run in my data center, but 20 application I'll use cloud because I need more agility compared to data center, and I need more flexibility, deployment flexibility, and might be those are built for cloud native applications. So you can choose, right? So that's called a hybrid. And today you take any research, any third party which are talking about, most of them are talking about hybrid cloud deployments. Every organization is talking about, they don't no application enterprise is looking at deploying everything on prem or everything on cloud. They're looking at deploying in a manner wherein they're selecting applications which should be deployed on prem or which should be deployed on cloud. Second important criteria: how to access front end protocols, right? Whether it is file, block, NVMe, like I told you, all block storage. For block storage, what is the protocol? Whether the customer is okay with using iSCSI, he doesn't have a performance requirement, or latency is not a concern for him, and he is okay not to deploy fiber channel switches for their environment, or he's looking at more latency, less latency environment, and he's looking at NVMe kind of protocol, right? So that also you have to, in block also you have to decide where I want to move, because every aspect will have cost and performance or non-performance added. So this is very important. File protocol. If it is file storage, which protocol he is going to be accessing, whether these are most of Linux clients or these are Windows clients or mix of Linux Windows. Will I have a file system where a Linux slide or I write a file through NFS and read through SMB? There are many of the applications which are built like that as well, right? Or I should look for object storage where I need a flat structure. I don't need hierarchy like file structure in terms of file and folders. I need a flat structure, single namespace for my petabytes of file environment which I have. Or should I look for a storage which supports everything, right? File, block, object on a single platform. The other important thing is media preferred. So because media plays a major role, when I talk about media, it is the drives which goes in the storage, physical drives, right? Whether it is cloud, even if you go to cloud, you choose drives, whether I need a SSD or I need a lower performance drives. Those you have option of choosing. If you choose SSD, your cost will go up, but your performance will also, it will guarantee you more performance, less latency and higher IOPS. So that's how you choose media based on requirement, whether on-prem also, whether I have option of 7.2K, which are large capacity drives, or 10K less capacity drives, or SSD, which are performance drives, or we should look for NVMe based. Right now, most of the vendors, cloud on-prem, they are providing NVMe based solid state drive to drive performance. One of the most critical thing is performance, right? Now you have to choose right controllers, right storage. When you're talking about, even if in cloud or low or on-prem, you have to tell your vendor that I have so many users logging into my system at a given point of time. Might be so performance for a bank versus a small organization will be different, right? Bank will need 10 lakh, 20 lakh IOPS from their storage at a given point of time. Small organization might need 50, 60 lakhs, so 56,000 IOPS maximum. IOPS is input output per second. For files, we generally performance is derived in throughput, throughput per second. What is the per second throughput which we are getting for a file environment? Protection, very important part. So you've stored your data, you know how to access it. That is good. Now you are getting a performance that's even better from a storage. Now, what is the critical part? Protection, right? Protection, local protection first. So I am not talking about any disaster recovery site or anything. Local protection. How you build a RAID on top of your drives. What is the drive failure you are going to be choosing? So suppose I lose one drive, I'll not lose my data. Two drives, I should not lose my data. Three drives, concurrent failure, I should not lose my data. So you design your solution on that. Also, you keep multiple snapshot for particular data. A snapshot is the picture of that particular data at that particular time. These are pointer based data, and this is not actual data, just the pointers. So if you have some deletion, if you have some change in data where you want to revert back to last state of that particular data, you should be able to do it. I'll cover this in little bit more detail. Although I'm not getting deep dive into any of the technology, but I'm just doing it. And protection from any logical or malicious events like any virus attack, ransomware attacks. So cyber security is also very critical for any organization right now, right? How you are managing cyber security. Now, you have talked about local data center. Now we'll talk about DC-DR failure. I have built a DC at a X location where my critical data is stored and I'm running my applications there, my core production application. What happens if some natural calamity happens, any flood, fire, anything can happen, right? You'll lose your data. So organization uh, build their data center, their strategy as even if I lose my DC, my data should be secured. And even if I lose my DC, my data and my operation should not hurt. So it is business continuity. You can build any of those. Everything is costing you additional, whether on-prem or cloud. So in cloud also, you don't want to stay your data in a single region. You for redundancy, you will build. I'll have one Mumbai region. Please replicate my data to another region, probably outside of the country or within country to a different region, right? So likewise, in on-prem, you have a data center, you are building a DC at your location and DR at your secondary office or any colo location, can be. And RPO, RTO is, I'll explain about that in going slide, what is RPO and RTO. Many of you might be knowing, but I'll reiterate all those points. And so there are different types of data protection, 2DC, 3DC, 3DC, zero data loss, mostly financial bank and financial institution where data is very critical. They deploy 3DC where they cannot afford losing even single IO which is coming and written and committed to the cache. So think about example, I'm withdrawing money from my ATM. I've withdrawn money and that IO is written on the drive or the storage, and the storage failed and I lose the data, right? So that should not be the case. So they build, if any IO is committed, you should have at least 3 copies plus backup copies are separate, right? In terms of any event of failure or anything, the storage should always be able to save the data. You should not lose any of data. So there are different kind of replication methodology: 2DC, 2DC, zero RPO. There is 2DC synchronous and asynchronous. Synchronous where I don't lose any data, but there are some flips for that as well when you do synchronous. Likewise, 3DC, you have one synchronous copy, other asynchronous copy, and then you have a delta replication where you are storing the data, same data at 3 different locations, right? So those are important. So I'll give you ONTAP platform overview. ONTAP is nothing but our NetApp operating system. But think about it as most of the storage vendors offer same kind of offerings here and there in terms of security and all. But enterprise players like Dell EMC, Dell EMC, now it is all Dell, Hitachi, HP, NetApp, Pure, vendors like Microsoft, AWS, GCP. They offer platform which is robust. I'm not telling that everybody there are competition, but yeah, everybody provides similar kind of platform with some plus and minus in every department. So on ONTAP, I'll just run through fast on this ONTAP part because so the storage should have capability to add capacity. So I'm buying a storage is a building block. Tomorrow, so I'm buying for 1 year usage, but suddenly my customer has grown and I need more storage for storing the data because my data is growing. I have bought for suppose 100 TB capacity. Now I should have capability on the storage to add the drives or add the capacity at any given point of time without adding performance, right? So that is one criteria. Second, I should be able to scale out. This is called a scale up. Now I should be able to scale out. So I am buying a storage and telling that I need 100K IOPS. But since my requirement has grown, since that time my requirement has grown, and now my requirement for IOPS is 200K. So I should be able to add performance at any given point of time, right? So it is called scale out. Not all vendors provide scale up and scale out both. Scale up and scale out will help you add capacity and performance at any given point of time without disrupting your IO. So you can start with small and you can build your data center on top of it. And you can scale out to cloud as well. Plus, these are the protocols which I spoke. The storage should support multiple protocol, NFS, SMB, our file protocol, FTP, iSCSI, FC or NVMe, TCP, S3. S3 is the object protocol. So all these are NAS and S3 are the part of data, and the storage clusters to support every kind of data, right? Whether it is file or block, you should be able to store it. You should be able to build your pipeline on top of it if you are looking to build a data lake and utilize for AI machine learning. What kind of drive protection? Very basic. This is RAID 5, 6, one single drive failure within a RAID group. I don't want to get into RAID group explanation, but those who understands, dual drive failure, RAID 6 is 2 drive in a RAID group failure, and RAID tech is something which is offered by very less number of vendors, where 3 drive can be concurrent failure can be protected within a same environment, right? We are talking about single storage. So on top of it, we build snapshot, we build replication DCDR. So that's why there are multiple protection mechanism built across storage so that your data is always saved. This is local storage, local protection, which is also called as RAID, which also helps in giving the performance. What is generally, just to give you example, RAID is just when we bunch number of drives. So storage, there are different capacity of drives like SSD. Right now I have 15 TB, but if your requirement is 500 TB, you will have to stack 15 TB drives, multiple of those. How you logically present that as a single to a host, that's basically a RAID. And 5, 6 are drive failure. It tells basically how many drive failure it can withstand within a single RAID group. What are efficiency technologies? Right now, most of the vendors or most of the on-prem or or cloud vendors provide all flash-based storage, right? And all flash are costly when it comes to price. Although it gives a lot of performance, but why all flash is getting adopted, but it doesn't become expensive because it helps storing data more efficiently. So like vendors like NetApp can provide 4:1 data efficiency on their block environment or for databases. So it means on a 10 TB of suppose 100 TB of physical storage, you can store 400 TB of logical data because of these technologies: snapshot, flex clones, thin provisioning, compression, deduplication. Deduplication is what, any block I'll not store it twice, only the pointers will get stored. Compression, you already know, we compress the data while storing. Compaction means every 4K block will be full when we are writing it, so that no blocks get waste. So by this we can achieve a lot. So think about, you are going to buy a 100 TB storage on a flash or a hybrid. On an NLSAS, you will buy 100 TB, but when it 400 TB requirement on a NLSAS drive you are going to buy, you will buy a 400 TB plus you will not meet the performance and all those things. Those are secondary. I'm just talking about right now storing in terms of capacity. On a all flash, you will just buy 100 TB because it is space efficient. It provides deduplication and compression. Right. Now we come to data protection. I have already spoken now, but I'll more define in terms of RPRT. Any questions till now? And if somebody can unmute and tell if I am audible, is it going well? I should slow down.
Yes, you are audible.
Okay. If anybody has any questions, please do let me know. Yeah. Now data protection. Now I was talking about something called as recovery point objective and recovery time objective. very critical for designing a solution, right? Recovery point, what is RPO? How much data loss I can bear? So suppose I am an organization, I am writing data. I from morning to night, my data is getting saved. I am saving on. You think from an individual perspective, I'll not talk example of organization. On my laptop, I'm saving my files and this that. I'm morning I come to office, I work, or I come to college, I work for full day. Now you will tell ki I am okay losing data for 6 hours. I'm fine, but beyond it, it should not be beyond it. So within 6 hours, okay, I have my memory, I can recreate it. But and what is recovery time objective? How much data you can lose is recovery point, recovery time. After I lose my data, after my environment going down, in how much time I can recover that, right? How much time I can come back to business normal. Uh, Suppose my drive fails, how much time it will take for me to replace the drive? So this is called. Now there are different technologies which are used for backup or storing, right? Now when we talk about tape or tape drive or a VTL, which is older technology, many of the organizations use for archival purpose right now, not for basically. Most of them has moved out from tape and they are using disk-based backup for their backup strategy. But yeah, tapes are still there for archival and long-term retention of data because those are cheap. They come at very low cost. So what is my recovery point objective? So here you can see the highest in tape recovery point objective is highest in and time objective in highest in tape, because tapes are medium where you'll find tape, search tape, come bring the tape, put it in the driver, run the tape, then understand which are files you have to copy and then come back, right? So it will take time because it it will take time. Plus on a tape you cannot do tape backup every 10 minutes or every 1 hour, right? Generally a tape backup is built once in a day or once in a week. Depends what is the use case. Second, D2D appliance where disk to disk appliance where your recovery point and time reduces. Lowest is when you do synchronous replication, almost zero. And there's something called as, we call it snap mirror, but everybody has a different, like, Hitachi will call this GAD, and all these will have a zero RPO RTO. So you can build, but the underline is your application should understand zero RPO RTO. Something like a Microsoft cluster or VMware cluster, they understand. If I build a DCDR with an application or Oracle RAC, right? If my application doesn't understand zero RPO RTO, then in terms of RPO you'll be zero. You'll not lose the data, but RTO you have to still go and attach that particular volume to the host at DR. If your application understand, your failover failback happens seamlessly. So that's how you can achieve zero RPO RTO. Snapshot, I already told you, these are like a photo of particular type. It is like when you take a picture of yourself. So I'm just giving you a layman example wherein I take your picture at 16 years age, and then I take a picture at 30 years of age. 30 years of age, you lost your hair. You want to go back. In real world, it is not possible. In snapshot, if you take snapshot, you can go back and restore your 16 year of age photo, something like that, right? So that's how the snapshot technology helps. Flex clone is something in an environment where suppose I have 100 TB of volume and my database administrator is working on that. They want to create a similar copy of that volume and they want to do some kind of research or development on that particular database or a file system. They should be able to do it without doubling the capacity requirement. So suppose you have 100 GB of database, you don't need 100 GB of clone and give it to a database developer to go and test or develop something. No, you just need to take a snapshot and give the flex clone and give a clone to them. Only the changes will get stored. No additional, it will not store anything twice. So this is one of the efficiency technology which I was talking about, by which you can save a lot of space. Very critical part, tamper-proof snapshot. So you have there are a lot of cyber threats happening today in today's environment where there is ransomware attack happening. Even in dark side, I've seen people coming with infected laptops or pen drives, inserting it within the environment, and then it gets ransomware. It gets cyber attacked, right? And a lot of money gets lost in those scenarios. You should have a technology wherein it doesn't allow a data to get manipulated once it is stored, right? So we have something in most of the environment like Commvault, Veeam, different technologies have developed similar kind of technology. NetApp has something called a SnapLock, which is a warm technology. Generally, you store it once, you won't be able to delete it. But in terms of ransomware, I'll cover that because I'll cover the security part in a later slide. Like I told you, replication technology, it can be sync, async, can be on cloud. You want to do a backup on cloud. Everything is a technology to protect your data, right, against failure of a location, against any natural calamity or any other kind of fire or power failure. Anything can happen, right? If you lose your data, you can build your strategy in terms of cascading or like. So here are the topologies. This is to bidirectional DCDR, two-site replication. One side goes down, other will pick up. There is something called as cascade, wherein three site A to B to C, your data is getting replicated. If anything happens to site A, B also, your C site is your data is still there. Fan in, fan out, you can understand from how the data is getting supported. So there are different type of use cases who uses this, right? I don't want to get into the use cases, but every technology has a different use case. Not everybody will have fan in, fan out kind of technology requirement or cascading, right? Everyone has a different use case for protecting the data. So that's how. And there are synchronous mirror where active. Like I told you, SAP, the Linux operating system, Oracle, VMware, those are cluster-aware operating system, and you can have DC-DR running application simultaneously. Both are getting used as a DC-DC, active cluster, and you can have a failover, failback at any given point of time with zero RPO RTO, right? Because these are cluster-aware. Similarly, in Metro cluster. Now, again, protection is one part. So both are different. Protection is how you protect your data against deletion, against any fire, natural calamity, how you protect your data, DC-DR, 3DC, and all. How many copies you keep, how you back up. Those are protection part from the storage perspective. Now, security. Security is biggest threat: virus attacks, ransomware attacks, right? How your data is secure, or a malicious user. Today in your office, your boss was, or you are a boss, you are not in a good mood, and you have said something to your subordinate, something which he didn't like, and he wanted to take a revenge out of you. He comes and deletes one file, right? Now, if he is able to delete it, you lose your job, right? So I'm just giving you one example, and don't take me wrong. These are some wrong examples because related security, I can't. I have to give you these examples, right, so that you can relate. So this is very critical, right? And these are very, and these are typical. So from last 17 years, I have seen these kinds of cases. Employee leaving the organization, taking a copy or doing something wrong with the data, right? Leaving the organizations with a bad experience, deleting. So all these are the experiences which can happen and which can help you, which can probably cost you lakhs and crores, and even data, there is no value to it, right? Everything is data for an organization. If you lose data, you lose your clients, you lose your customers. So there are many things which are involved. So you think about a bank which is holding your account. If they lose their data, how will you get money from that bank tomorrow if you go to ATM or do a Paytm? So understand from that perspective. So data is critical. Security is very critical for a data, right? Like I told you, data is the world's most valuable resource right now. Data is the new oil. People are telling it is a blood. If you think a body, it is like kind of blood within a body, something like that. Yeah, live blood for organization. Now, what are the technologies which help you safeguard data on the storage? You build a lot of technologies at perimeter using firewall, UTM devices. Then you have a host, resources, firewalls, and antivirus, anti-ransomware, and multiple other software which you use. But still, if the ransomware or the cyber guy or the bad guy is able to get into your environment somehow, like I told you, malicious laptop, malicious pen drive, or he has a hack of your firewall security, even if you're dark side. So I've seen ransomware attack happening even at a dark side, which is cut from outside environment. But still, There are attacks which happens wherein ransomware goes that 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 software goes and sits on host, reads the environment and then attacks, right? So you should have mechanism at storage level. The artificial today the environment we are talking about artificial intelligence. The storage should have the intelligence built to understand that I have been attacked and this is my ransomware attack and I should be able to safeguard it. So there are multiple protection mechanism which are built for safeguarding the storage. Multi-factor authentication, wherein if I am logging into a system, I should have authentication first, like how you do in bank. You have a OTP, or you get a SMS, or you get a mail with a code, and then you should be able to log in. Data at rest encryption. Whatever data is stored on the drives should be encrypted. On a storage should be encrypted. Even when I am replicating from DC to disaster site, it should be encrypted. Ransomware attack proof. It should have warm capability, so that if there is some very critical data, which finance data or very critical data when it comes to healthcare organization or patient data, when it comes to organization student data, I should not lose any of the data. What maybe if somebody wants to delete it, manipulate it, it should not happen in a particular period of 7 years, 10 years. You can put that date while storing that particular data. Secure boot. When I'm booting, my image should always be checked. If it is not malicious, I'm fine to do the rebooting. Audit logging. Something goes wrong, I should be able to audit or suppose, like I told you, somebody deletes the file, I should be able to audit who has deleted it. I should have this thing. Secure purge. I am so my drive has failed on a particular hardware. Now I'm returning the drive to OEM, but I should have, or I'm returning it to partner, any of the IT organization. I'm returning the drives. Now I should get the confirmation that my data is completely deleted and nobody should be able to recover the data. That's very important, right? Many of the government organization, bank, security organizations like DRDO, they ask for these kind of features. Certifications. How the certifications are defined. Mostly we in India also we follow Department of Defense, US, and those US based certification mostly. Although India has a few of the certification, but still globally American certifications are followed by most of the organization, and they are the top one, most difficult to achieve. Secure multi-tenancy. Multi-tenancy in the sense, in a same hardware or in a same storage, you should be able to carve out multiple storages for different departments, or those departments should be all those storages, I should say, virtual storage should function separately without interfering into each other. And data replication. When we are replicating data from DC to DR to cloud in a hybrid environment, it should be encrypted. These are some figures which are very staggering, and I have mentioned from where I have taken these figures. These are 2022, and I can tell you from my experience, I hear this almost every week, daily, with some or other customer today. Right? It has become, cybersecurity has become very, very critical. When you are storing the data, many of you might have already, I don't know, experienced it or might have heard the stories of ransomware attack happening. There are many which are happening in US. It is much more. India is starting picking up big time. So cybersecurity is very, very much critical. You can see the amount of money, 4.5 million, and the amount of time and money which is almost on 40.5 million in 2022. Today we are sitting in 2024. I think it has grown exponentially, if I have to talk these numbers. So the storage should have ability to protect, detect, and recover. How do you protect? The storage should have, so whenever a ransomware and virus or any of those kind of attack happens, right? When you deploy a storage in cloud or on-prem, when you deploy a storage, suppose you are a organization or you are a education college. Now you store some kind of data. University stores some kind of data. Suppose you have a database, you have student information, you have mark sheets, or you have different curriculums which you are going to be storing. So there is a pattern to your data file. This is the database. So when storage is intelligent. When it comes and sits in your data center, it learns first what kind of data you are storing, how it, so it knows the pattern for 15 days, 30 days, 1 year, 6 months. It learns. It has learned that it knows what kind of data you are going to put. If attack happens, storage should have capability to understand, no, this is not the pattern, or this is not the data which I store. There is something wrong, right? And at that time, it should have, it takes a it should take a temper proof snapshot wherein your data is safeguarded. Even if some get encrypted, most of the data gets safeguarded. Detected it and send a alarm to the admin and different stakeholders within the organization, and then it should have a capability to restore the data from the tamper-proof snapshot. Many of the time when cyber attack, then hackers comes into, they first encrypt the data, then second where they go. I told you snapshot. Snapshot is one of the data protection mechanisms. They go to snapshot, they delete the snapshot so that you won't be able to recover. They try find out if you have a DR, they go and delete the DR. So all those things. But still, when you take a, like I told you, warm tamper-proof tamper-proof snapshot helps you with non-deletion, because storage understand I have been attacked. It will take a tamper-proof snapshot. Now, even if it is an admin who has done this attack and he wants to delete, he won't be able to delete. So that kind of mechanism should be there. Like I told you, this is explaining about multi-admin and different kind of verification on this thing. Yeah. Any questions? I'll pause for 2 minutes. You think if there is any question, let me know. If there is no, you can also put it in chat. Yep. So we will move to object storage, which is the most or highest in terms of growth. We are seeing lot of requirements coming for object storage. Simple reason is easy to access through APIs. Any application can integrate through S3 APIs. Deployment flexibility. You can have a cloud native application, cloud birth application who has taken birth in cloud can be ported to native or can be run anywhere because it follows a simple S3 protocol. Any microservices based applications mostly use S3 as their native storage. So these are some of the factors, plus lot of increase in unstructured data. There is huge amount of unstructured data coming from, like I told you, ADAS is one of the example. Likewise, there are multiple examples, like face recognition softwares, threat recognition within an organization. You want to create, online face recognition punching for your employees. And if there is any rogue employee which tries to come in, it should give an alarm. Those kind of environment, right? So those needs lot of data, big data lake in terms of for learning, and also then there comes you need to have a single namespace. You cannot have multiple files and shares, to access, or different storages to access it. You should be able to build petabytes of data lake space and then build a AI or ML, AI ML, use cases, pipelines on top of it. So object storage, why it has increased? You can see the amount of data which is going to be there in object storage by 2025. So why object storage is critical, right? Massive unstructured data growth continues to drive, like I told you, IDC by 20 to 81% of the data created will be unstructured. So like I told you, even if you see a normal small organization or think about a college or university itself, you will have a database size will be small, maximum GBs or maximum 500 GB, 1 TB. But what is the major portion of the data? It is unstructured data, files, your different kind of, it is mostly files, your JPEG, PDF, Word, Excel. In your laptop, you see most of them is, there are application data, but most of them is files, right? Same way organization. So it is 81. I have seen almost in India, 90% of data in any organizations, it is mostly unstructured data, right? Unstructured means it doesn't have a structure, like I explained you, right? What are the key drivers of adopting to object storage? Artificial intelligence is one of the major, because building artificial intelligence need lot of data, need a data lake. On top of it, you can build a pipeline so that you can get more intelligence out of what you are building. And machine learning, obviously IoT applications. There are a lot of IoT applications which are sensor based applications, which stores a lot of data, and based on that, it develops AI and ML on the environment. S3 adoption has increased big time on cloud. Like I told you, on cloud or on prem, S3 is becoming one of the major de facto when it comes to application accessing the data storage. And yeah, these are the major criteria. And hybrid cloud, like I told you, if there is a cloud native born application, if you want to port that application to native should understand S3 as well. So S3 is a protocol which is used for accessing object. That's how the most of the application which are very new, latest generation applications are understanding S3. Although most of the legacy application has issues with dealing with object storage, but yeah, all latest Microsoft based applications are using object storage as their native storage for data. How does object storage work? Basically, you generally have a load balancer, and this is deployment which is on-prem deployment I'm talking about, right? I'm not talking about cloud deployment. On-prem deployment, you have a load balancer, and then you have object storage, and you have information lifecycle management replication going on. What is information lifecycle management? When you define that I will have, so a file is called as object in object storage. Why it is object? Because it has a portion of data and a metadata. Metadata basically is the file characteristics in terms of when it is created, or you want to put additional custom metadata. Suppose there is a hospital which wants to store a file, a PACS file, and want to put a custom metadata in terms of patient information, name, age, disease, and all those things, and then it wants to store, right? All those are called custom metadata. So object is a storage. When it stores a data, it is one part is data and one is metadata. That's how the object storage. So information lifecycle management, wherein how many copies of data you want to store, 1 or 3, how many locations you want to spread, what is the capacity, what is the failure rate you are looking at when doing the implementation, right? So, and also biggest use case right now, also even after AI and whatever I talked, most of the biggest use case right now for object storage is archiving, which is storing a data for a longer period. One, second, backup, right? Right now also it is one of the biggest. But yeah, there are use cases around AI, machine learning, IoT, which is evolving, like I told you, right? So those are evolving, but right now these are the biggest use cases still. When we talk about, I talked about site protection. It is different from these are erasure coding. It is different from RAID, which I spoke on storage. Object is stored differently. Like I told you, you will have 3 different sites. It is not replicating, but we keep the copies, right? Or when you define an object and when you want to keep a copy, you will always, suppose you want to keep 2 copies, 3 copies, the object storage will keep 2, 3 copies, 1 copy locally, other copy will be at other location, other copy will be other location. If you heard about global file system, it is similar architecture, right? Where even if you have an application which is accessing data, when you are in Bangalore, you will access the same data locally from Bangalore data center. Suppose you move to Gurgaon, Faridabad, Delhi, and and your data center is there, you will be able to access locally. So everything is locally present. You have multiple copies. Likewise, it can sustain. Suppose you have a data centers in Delhi, Bangalore, and Boston. Suppose Delhi goes down one, you still don't lose data because you have 2. So you build. Likewise, you can build 16 different data centers. Likewise, a single namespace across. It is single namespace across. I'm talking about. Okay, I'm not talking about any file or folder architecture here. So like I told you, life cycle, reliability, dynamic, intelligent, and location. You can have multiple location, DC, DR. As I told you, it will be always you when object is created, it will it be read locally if you build information lifecycle management across that. This is one of the deployments where we talk about object storage. See, I told you Seattle, Denver, New York, there is object storage. Now, new applications are accessing from Denver. Likewise, you are also replicating the object storage S3 to cloud like AWS GCP. You have compliance data which you have kept in New York. You have archive. These are different use cases. And also there is required, like I told you, archival, right? When it comes to file environment within an organization, like I told you, 90% of file is of an environment is file. Now, since you are not in front of me, but ask yourself, in your laptop, in your personal computer or desktop, you have 500 GB of capacity drive or 1 TB of capacity drive, where you will have thousands of files stored. How many files do you access on daily basis? It will be less than 5%, and 5% is also a higher number. It might be 1 or 2% in many of the cases, 90%. Now, what happens to that additional file? Now, here it is laptop where you have already bought, right? But when it comes to enterprise, when you keep these files on a, like I told you, flash drives, NVMe based drive, your cost becomes really, really high. You don't want to spend so much of cost when the data is not getting accessed. So you can always tier the data to object storage, because object storage is always larger capacity and lower at cost. So you can always tier that data using different technologies. In NetApp, we call it fabric pool. From a production storage to object storage, archive the data online. When you archive it, your stuff will always remain. So your architecture will not change in terms of backend file system, right? You wherever folder file, you will still be able to see those folder and files. But when you double click it, it will rehydrate from object storage, which is backend. It might take some time. Latency will be there, but still you are saving a lot of cost, because 90% of data is unstructured, like I told you. And out of 90%, 85% of data once created never touched, or even if created, touched and then never touched. Only 5% of data is hot in any of the environment. And I have given you a good example of laptop. Think, ask yourself, it is the same with everybody, right? So object storage plays a very big role in also reducing the cost of storage within the environment, apart from all what I spoke. So like I told you, what used to be use case for object storage? It used to be cold archive, long-term retention, active archive, blob storage, app storage, HPC, analytics. You see, analytics, HPC, all these were very small use cases earlier. Now it has evolved, and you see, analytics has become biggest use case, right? AI, active archive block, HPC, these are coming more and more bigger use cases. That's why most of the vendors have all flash object storage also introduced. Although object storage we used to have a de facto understanding, they are buying for archival, they are buying for backup, but now customers are buying object storage for their AI ML applications to use it natively, right? That's and where they need performance, they're looking for flash drives on those. Now these are some of the pipelines on object data, cloud data pipelines on a hybrid cloud environments, wherein I create a object storage. If I have inserted a picture, like first in left, I have inserted a picture on storage grid. Storage grid is NetApp object storage, and it has created a Lambda, Amazon Lambda. It has created a server which will help build Amazon recognition and store the data. So it's kind of a pipeline which is created. Whenever I insert an object to a storage grid, this pipeline will get triggered, and I will store that object with identification, with adding more of metadata on top of it. Second is cloud mirroring. I am having storage grid at my DC. I want to mirror my data to Amazon, to Google, because I want to have resiliency across all the clouds. I can do that, right? I can do that as well. Elasticsearch, it can integrate with Elasticsearch. It can have a cloud tiering on Glacier. You can tier. So even in object storage, you can tier your data, which is not going to be used to lower cost, tiers like Glacier on Amazon. This is again why data, this single, whatever I spoke, why object storage, single data lake for all your requirements, whether it is Kafka, Spark, Vertica, Splunk, these are, or it is connected cars, Hadoop. You are, because you have petabytes of underlying object storage, you are reading data and writing data on the same object storage, or on the same object you are getting your intelligence built into it. That's the robust way of building your artificial intelligence, machine learning and analytics for any of the organizations. So that's how I conclude for today. If you have any questions, you can ask. Thank you very much for your time. Yes, sir, over to you. If there are any questions. I think I am on time, whatever I have committed.
Vinayji has question. Please ask question.
Hello, sir. Vinay this side.
Hi, Vinay.
Yeah. Sir, Amazon and IBM provide some analytical tools.
Hmm.
How these tools are differ from the Hadoop and are we are using for the analytics?
Hadoop you are building on your own. When Amazon provides, they have built their own, like, for example, Amazon recognition, right? This is one tool which helps you recognize or find the photo. When you insert some kind of photo, it finds, it can learn, it knows what the photo is, because it has a gallery which it can help you recognize that photo and store on a storage. Likewise, they have built their own. Hadoop, it's again a file system which you have built locally, and it is very, very local for our organization. You can build Hadoop on cloud also, your own Hadoop that is there. But there it is enterprise. So think about, I should give you an example of CentOS versus a Red Hat OS, right? Both are same flavors, but Red Hat has got its own support, its own flavor on top of it. Likewise.
So CentOS is a more reliable than the
Red Hat
Hadoop?
OS is enterprise version. CentOS is a free version. So understand from that perspective, right? With
Okay,
CentOS,
okay.
you go and build but you're not spending anything on CentOS. It is free, available. But you are spending money on when you're buying a Red Hat license, right? But you are getting services on top of it. There are a lot of services and a lot of other features which they build on top of their operating system and give, right? So those services you will not get in CentOS, although both are same. But I'm just giving an example. One is commercially available, one is you are building it. Hadoop you can build.
Okay, I have one more question, Sunilji.
Yes, sir.
I mean, looking into the context of AI, I mean, probably we found that a lot of data is being used, and it is being widely said that this concept of AI is actually being possible because of this wide domain of data that is being available.
Absolutely.
But at the same point, then once we are talking about this cyber security or the cyber threats being pertaining to all these things, how we are going to map out these things, because everything, I mean, when even the cyber part is being taken into the case, they are getting into the data, and
Yes.
at the same point of time when we are talking about our AI algorithms and everything, they are again going to deep down into the data, and the data in context is not available on the RAM all the time because this is very huge data. So how these things are actually related, I mean, on any perspective, if we need to understand this concept.
Yeah. So see, whenever a ransomware attack happens, so I don't want to name a customer. So it's a customer, it's a large, very large government customer, and manages security for one of the cities. Okay, globally, I don't want to name. Now they got ransomware attacked, and they have almost it's a very big 50 petabyte plus of data stored, right? Now they got ransomware attacked. Now when ransomware attack happens, customer is not concerned if they have attacked an encrypted host, which is servers. It is fine, right? They can remove that host from cluster and add new host. Those can be the infected host. But if your data is getting encrypted by a ransomware guy, in those scenarios, because when ransomware attack happens, right, the the attacker will not only encrypt your storage data. Like I told you, why the security is important. It will go and delete your snapshots which you have taken for backup. It will go and find within your organization. That's why I told you nowadays I don't want to name because I can't name the organization where it was a dark site. The the server or host got infected long back. It stood in that for some time. It was there infected on the host, not doing anything on those hosts. It was just spreading and understanding the environment. And then in encrypted, it deleted the backup because it understood where my backup copy is going, where my DR is going, and it did all these things, right? It deleted. Now that organization had to pay because they never had that kind of security built into it. That's why I told you storage plays very critical role because it safeguards the data. Now, why I talked about worm, or I should say ransomware attack, snapshot copies, snaplock copies. When your storage understands I have been attacked or there is some pattern change which has happened. When it does a snap lock, even if you try, I have a demo, but I didn't included that. But even if you are, suppose an admin, you do a ransomware attack on your organization and you try to delete it on a storage. Storage should have intelligence to safeguard it. So that's why host level is okay and people can tolerate. But at storage, when your data is there, even if your AI applications are running, they have done a lot of work. They have safeguarded the data. Where they save the data, output will be stored on again storage. If that is getting logged, you organization have to pay a big amount, like I have shown here, and they pay a big amount. Once it is a trap, and once they pay a big amount, how much time it takes them to recover, that also plays a major role. That's an organization which is running 24/7. I have taken 10 days to recover. Think about the loss that has occurred. It is not only data loss or whatever I have paid. I've also lost 10 days. So that's also important. So your strategy at the storage level should be, your storage should understand that this is your ransomware attack. It should have a mechanism to protect, detect, and recover. So I should be able to protect it. Suppose the protection has failed and it has gone into some of the files. I should be able to detect it, and I should have a mechanism to recover it. All should be there in the storage. The data is most critical. Matlab, you talk about it because I have 17 plus years of experience. Like I told you, BFSI, government, and I deal with customer. I am the front-facing guy. I go meet CIOs and CSOs, right? And their biggest concern is ransomware right now, cyber threats. They first talk about what feature you have to safeguard my data. Now earlier they used to say what performance, what is the redundancy, all those things are, what is the capacity. Now they talk about what feature, how I can safeguard my data. That's one of the biggest concern right now, which is growing in India. US, I think every hour or 2 hours, one organization gets ransomware attacked.
Probably, I mean, it is even we have those security mechanisms, still they are being targeted. And
Yes, yes, yes,
primarily looking into this aspect that different types of storage have different capabilities in terms of handling these
yes,
issues.
yes. So we should look for the storage which can meet your requirement, your use case, how you are safeguarding your data. So when you are deciding on storage, you should always have multiple technologies which can back up your ransomware protection story.
In fact, it has been seen that it is not about the organization, it is about the individual also. They are getting these
Absolutely,
sort
yes.
of problems.
Yes, yes, yes. The only thing is, unfortunately, NetApp or Hitachi or Dell or any of those companies, they build for enterprise. They don't for end user. They don't build storage for end user. But yeah, it is a problem for everyone.
And again, I mean, once we are talking about this concept beyond storage, even about the application parts. I mean, let
Hmm,
me
hmm,
say, because for a few days we are dealing with these AI and everything. And there is one aspect that we generally talked about, bias. So even when we are talking about the storage and everything pertaining to it, I mean, it is again coming out from the data, and that data is being biased through these apps and everything, because I mean, even the cyber attack is somewhere not to hide or steal, but it manipulates the things. So
Absolutely.
this definitely going to make a great impact over to the application part of your AI.
Yes, 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 definitely. So, like I told you, see, security right now is a 360 degree within a data center. It cannot be on storage. You have to have a perimeter security. You have to have a security at host. You have to have security at your load balancers. Everything, because security is paramount. 360 degree. Right now, cyber attacks, the way it is happening, a few, I think last year or something, your whole grid went down, right? Because of cyber attack, Western grid on a power. Think about a scenario: your whole country power goes down because of a cyber attack. So it is so huge. That's why it is taken very, very seriously by government, by organizations, large enterprise, banking. All those are like, they're making multiple layers of security to withstand any of these kind of challenges. Storage is one of them, because storage is last I should say restore of defense, because in a data center, when a host, a write happens or a read happens, it comes from outside last, and and happens at storage. It is written or not, committed or not, or acknowledged, or it read happens from storage. So your last destination and most important part of storage. So every money getting spent on cybersecurity is to store to protect your data, which is the critical part. Whether it's storage, that's why it is not only storage. You have to build your cyber security across your data center, across every layer, so that it never reaches storage. I'm talking to worst. If it reaches, okay, storage should have the capability.
And any other questions from any participant? I mean, before we thank our speaker of the day, the first session. Any questions from the participants?
Then how the AI help us to provide storage security? Because till now, I feel that we are not be provide that much of the security for our storage, because many type of the attacks, like as you told, ransomware attack and DDoS attack,
Mm-hmm.
are the every day and each and time they are to destroy our data, and
Mm-hmm.
data is the one of the crucial part of our online work.
Mm-hmm.
So can AI play a good role,
Okay,
or provide us the
a very
any
good
kind of
question.
the facility, then we can secure our
AI
storage?
plays AI plays the biggest role at a storage for protecting, detecting, and recovering from ransomware attack. How? Right? You have an operating system first. First layer of your operating system is always, like I told you, right? The storage should have intelligence to understand that I have got a ransomware attack, IO. Okay, somebody is trying to encrypt. So how it will understand? It is with the help of artificial intelligence on the operating system of the storage. Because you have deployed a storage, it understands the pattern. So for example, your particular laptop, you have a pattern. You go download copies from some other site. You download movies. You have pattern of downloading, but suddenly the pattern changes, and there is some exe or some file comes in and try to encrypt your data. Your laptop will not recognize, but storage should have capability, artificial intelligence capability, to understand that, yeah, this is not a normal IO which is happening, normal write which is coming. This is something malicious, so I should do a snap lock, or I should safeguard my data. So it will first stop that IO, plus it will take a snap lock snapshot, a copy of the data, so that even if you encrypt, you will be able to recover it. I'll show you one example, just if time allows. uh, just give me one minute. Okay, I'll share one uh, a small video which will help you understand how does a storage helps safeguard. I am resharing my screen. Okay, I'll run you a demo. Just see how storage intelligence will help. This is a simulated environment. Okay, so just bear with me. Where we have. Okay, this is a demo. Okay, you are able to hear. You are able to hear.
Yes. Yes, yes.
Sorry. Just I'll play this video and then I'll give a brief description. So now it is learning. Now it is learning. Now he is simulating a ransomware attack on that particular folder. A share, sorry. It is all logged. It understood that there is a ransom attack which has happened and has taken a snapshot copy, which is immutable copy. You cannot delete it. So he wants to delete a backup which storage has taken. It won't allow. From just a matter of one click, we have recovered. See, they've been copied. So this has shown you how AI built on operating system of a storage helped you detect, protect, and recover from a ransomware attack, which has happened. So that is how the storage technologies are getting used nowadays to help you recover from it. So that's why it is very important to have storage capability to detect, recover from a cyber attack. Yes, sir.
Thank you, Mr.
Nice
Mishra,
explanation.
Thank you very much.
thank you, sir, for that insightful session. Your expertise in cyber resilience and data storage has provided us with forward-thinking strategies for managing critical data infrastructure.
Thank you very much. And I'm happy if somebody needs any more help, they can send me a mail and I can help out. Thank you. I can disconnect, right?
Yes, thank you very much, Sanilji. Thank you very much.
Thanks, sir. Thank you. Thanks, everyone. Bye.
Thank you, sir.
Yes, sir. So we now move on to the second session of day 5, titled Redefined Computer Architecture for AI and ML Applications. This session will explore innovative approaches to computer architecture tailored to meet the demands of AI and machine learning, enhancing performance and efficiency.
We are privileged to have Professor John Jose, a distinguished faculty member from IIT Guwahati, as our speaker. With 10 years of academic and research experience, Professor Jose specializes in redefining computer architectures to optimize AI and ML applications.
Thank you, Professor Jose, for joining us. We look forward to your valuable insights. Over to you, sir.
I hope you can see the slide transitions.
Yes, sir.
Okay, you are able to see the first slide, right?
Yes, sir, it's visible.
And hope it is in the full screen mode.
Yes.
Okay. So on the outset, let me thank Professor Ajal Kaushik for giving me an opportunity to share my thoughts on this topic. I have gone through the program's wonderful diversity that has been included in the topic of AI and ML. And good to see a lot many participants are there. Don't know how many of them are actively participating because it's an evening time. And then this is a time wherein people are looking forward for the certificates, and then many ATAL FDPs are happening across the length and breadth of the country. So, and I wish to add my few points this, and then there are a lot of opportunities if some of you wish to collaborate with the IIT systems in general and IIT Guwahati in particular, where we have a strong AI group both at the application level and at the systems level. So let me start the talk by introducing the concept of redefining computer architecture for AI and ML applications. So as we have already seen, I hope you can see the second slide, right? Is the slide moving?
Yes, sir. Yes, sir.
Great. Okay. If there is any glitch, you let me know because I can see only the slides. So the other thing is not being shown. So that's the reason. Okay. So machine learning and AI is everywhere. I hope in your past sessions over this week long, you might have heard about different aspects of AI. So I need not talk about this. Where all AI can influence, what is AI? I think by this time, hopefully you all will know. What I wanted to introduce you with a big picture. So ultimately, AI is going to work on a computing device. AI cannot work on a wall, AI cannot work on a paper, AI cannot work on sand, it cannot work on water. Ultimately, AI is nothing but it is a class of programs, special programs, which upon execution will give an impact on what a machine can do, which can closely mimic the operation of a human brain. Now the question is whether our conventional computer system, something that some of you faculty members or scholars have seen, let's say 10 years before, whether an AI application, be it a face recognition program, a Grammarly program, a sentence checking program, or be it ChatGPT, will it work on our conventional computers or laptops? Or do you want any specific system to support an AI application? Okay, so that's the agenda of my talk. Is AI, so people who are from electronics domain, maybe from electrical engineering branch, they may feel AI is everything computer science. AI is actually a fusion of all engineering branches. And what is that my penny, my small kitty that I can add with respect to my area of specialization? Let me draw you to the very fundamental slide that we all learn at an undergraduate level, maybe a computer architecture or a microprocessor course, that anything that you wanted to do with the help of a computer, you will have a processor and then you will have a memory also. And it's basically this memory that is going to, this is going to help us. Okay. So what you see is in the memory, you are going to store a program and the program is being fetched by the processor one by one, decode and execute the task. So essentially, this is what we have learned, fundamental concepts of program execution. Programs are to be stored in memory of a computer. You have to fetch it, decode, fetch the operands, execute, store the result, and then move to the next generation, next instruction. Now let me sum to do that. Consider a simple fetch operation. You wanted to bring something from the memory of a system. So consider a simple instruction that you are going to take some content from a location 1000, which is in the memory of a computer, to a register, which is inside processor. So you know that your processor and memories are going to operate at different speed. What if you wanted to move something from memory into processor multiple times, let's say million times? So what I'm going to talk about is, you think that you have a very small child who just started speaking his words, is going to talk with you. Let's say you are busy with your 100 task and the child is slowly taking 1 or 2 minutes to complete one sentence. So hope you might have seen they take their own time and pace in which you communicate. So a very fast processor like you is going to hear from a child who is speaking very slowly. So if it is for, let's say, one sentence, they're talking about their favorite story, it's fine. What if the child is going to talk to you for the entire day? Millions of words he is going to tell one by one. So there obviously have a speed mismatch. You cannot do anything else, but the child is fully trying to connect with you. So when you try to do an operation from memory to bring it to processor to do an activity, when this has to be done over and again and again and again, what are the challenges? This is something called von Neumann bottleneck. This means, you know that in a computer, you have your storage that is being organized as a hierarchy. We have a very slow hard disk, then little bit faster main memory. We have levels of cache and CPU. So there are different speeds of CPU and memory. And then if you fetch anything from memory, it's going to be slow. When you do it over and over again, it's going to be a nightmare. So what I'm going to talk about is any kind of movement that is involved between your memory and your processor. Now let me draw your attention to something called Turing tariff. Let us say I wanted to perform an add operation, add R1, R2, R3. So I wanted to bring two values, put it in two registers, I wanted to add. But you are going to talk about a general purpose computer, what is called the cost of performing an operation on a general purpose hardware. So you have a small computer which can perform adding, subtraction, loading, multiplication, many things is there. So whatever be the instruction, you are going to put it inside your memory. Only upon fetching and decoding, you come to know whether it's an add instruction or a subtract or a multiply, store, move, whatever be the instruction, because the hardware is capable of performing any operation. That's what is called a general purpose hardware. So consider what has been shown here. You are going to fetch an instruction. Let's say it's taking 25 picojoules of energy, and then you are going to access the registers, generate some control signals. So essentially the final add operation maybe just 1 picojoules, the real add operation which you are doing to do with an adder. The rest everything is a built up. So those who are mothers, those who are interested in cooking, you may know that you will spend after your college hours, let's say 1 hour of cooking in the kitchen to make the dinner, and everybody come to the dinner table with 5 minute things are over. So the real eating process is just 1 minute or 2 minutes. But whereas how much of the time that is been involved with you, you have to fetch the vegetables, cut it, make the roti or rice, whatever it is, then arrange everything in the dining table. So this is called the overhead involved, whereas the actual eating operation is very less. So what happens? You are a general purpose. If you are a cook, you are a general purpose processor. You know how to take care of children's homework. You know how to cook. You know how to take care of your parents. You know how to take care of having a cordial relation with your neighbors. So you are a general purpose processor. Depending on the instruction that you do, you are capable of doing. This is exactly what I wanted to draw your attention. So anything that you need to fetch from the memory and then decoding it, it takes a lot of energy. whereas the actual instruction execution may take very small amount of time. So roughly it's at the order of 10x times to 4,000 times is the difference. So the purpose that I wanted to tell to motivate you is the real operation of an adding or any arithmetic operation that you wanted to do, its overhead is very small compared to the overhead involved in bringing something from the memory. This is exactly what is called Turing tariff. Means extra overhead that you might have to perform when you have a general purpose processor. So why was all this issue? Because your hardware doesn't know what is the operation. So I need to bring something. I need to understand what the operation is, and then only I'll be able to do. Now let us be trying to draw. This is called a hardware-centric approach. So when you talk about new generation applications like AI or ML, you are going to run on your conventional microprocessors, your conventional laptop or conventional desktop. Then the problem is it takes more time to do the operation because, as you all know, your neural network applications or AI ML applications consist of lot of layers of artificial neurons functionality that you may have to do there. So with the conventional hardware, it will not work. So you require a specialized hardware. You can do it. You require a specialized hardware. This is what is known as domain-specific accelerator. It is tailored for domain of certain class of application, let's say being graphics, being in neural networks, in advanced simulations, then mimicking what is going to be the temperature and heat equation, the genomics associated with manufacturing of vaccines, be it weather prediction. So what we are interested in this particular FDP is about in what way we need to redefine our conventional computing system when you are going to talk about neural network applications. I'm sure that this particular slide might have been shown by different people over the last 1 week. It's an artificial neuron. What it does, it takes inputs, perform a weight, and then perform the corresponding activity of a neuron, the input net function, and you have an activation function. So what it basically does, let us say if this is going to be a neural network, which is going to determine whether a given input image is a cat or not, it has to pass through the set of neurons and then ultimately produce whether the value is above a threshold, we call it as cat. If the value is below a threshold, then you tell it is not going to be a cat. So in short, how do you represent an artificial neurons task? All you know that artificial neurons consists of an input. So whatever is the input problem that you have, it has to be truncated into multiple inputs and they are fed into the system, which will perform an input multiplication with a weight. So this is a neural network, and then you basically have a matrix operation. The weight matrix is been divided with the input matrix, and this is what you do. Now look at this matrix. I want you to draw your attention into this. Imagine you have just one multiplier and one adder. So what you do, first you do, let's say this neural network, what is being shown here, if you wanted to do the same operation to be done on a computer, which has only one multiplier, you first mimic the activity of the first neuron by taking the inputs multiplied with its corresponding weight, store the result somewhere, go and mimic the second neuron's operation. That's what you do here, and multiplied with its corresponding weight, and then store it. Like that, one by one, you have to do all the neurons operation, and sometimes the output of one has to be added with. So the first one has to be added with the second one. That's exactly what you do here. So it involves a lot of data. Now, where is this W and I? These are stored in memory. From memory, you have to bring the weight. From memory, you have to bring the input value, multiply them, store it back. Take the next weight, next input, multiply them, store it back. Bring back the first stored value and second stored value, add it down. So it may look very fancy when you work in a software level of AI, whereas how this is being carried out, it consists of many of these neural network operations are nothing but matrix multiplication. So you require a hardware which is capable of metric multiplication. Now you imagine, let us say I have 6 such multipliers. So my W11 into I1 and W21 into I2 can be parallelly running. So now you have 6 multipliers, so all of them will be done together and I can immediately add. This will be much faster. So if your AI application run on a conventional computer with one multiplier and one adder versus you are going to work on an advanced microprocessor with the 6 multipliers and let's say 2 adders, it is going to be much more faster. So AI will not give you an advantage of things going to be quicker. AI will give you an output only if AI has a supportive work environment. Okay, it's just like you are thinking that no, you know so many items to cook. And then let's say you have a very conventional old stove with a very few utensils that you have. You have only, let's say, one tawa and then one kadai. Then you are being limited to using them one by one. What if you have a very sophisticated kitchen with many gadgets, tools, and appliances available? This is exactly. So you look from a conventional kitchen with limited accessories available to a modern kitchen with many things that is been available. So essentially, you can do so many things faster. So you're cooking, even though you are doing the same recipe on a conventional kitchen, it takes more time. With a modern kitchen with a lot of amenities, you can do things quickly. I'm sure you're familiar with this. This is yet another aspect of a neural network where I give an image and then you wanted to know whether it's an image of a Volvo car or not. So the image is being divided into smaller segments. They are fed into the input layers. They will go across the layers and ultimately it will tell whether it's a Volvo car or not. So as you all know that in the case of any deep neural network, we have let's say two phases. One is a training phase, which will help us to determine the weights and the biases. And then other one is known as an inference phase, where you give an input and then the system has to tell whether this satisfies a condition or not. So this is called supervised training algorithm. I'm sure that you are already aware of this. And then once the training is over, you are going to give an input and then already the trained system will tell you what this input is. So we have a training phase where with supervised mechanism, we adjust the weights. And then once the weights are being stabilized, then we have a testing phase where we are going to check whether a given input is going to make an impact or not. So this is the way how a conventional neural network interference work. Now, what are deep neural networks? We know that when there are more number of layers, it can perform more complex function. So this is just a quick recap of what you have already studied, and I'm slowly trying to connect this with a hardware approach. Now, let me try to bring your attention, which many of them might have already not covered. I wanted to do a deep neural network operation. And how do you do that? You have a hardware, which is a processing element, which can be a multiplier or an adder. So one of these neurons, what you see, this neuron's activity has to be carried out in this one processing element, which I am focusing. So what happens? The input value from the memory has to reach. This is a chip. What you see, it's a processor with the 16 processing units. It's a chip with 16 processing units. The inputs and the weight has to reach this corresponding processing element, and it will perform the multiplication. That's exactly what this neuron does. Similarly, the second processing element will mimic the operation of this. What is the challenge involved? In hardware, I have to bring the corresponding inputs and weights, get it multiplied. Now you know that the output of layer 1 is connected to the input of layer 2. So the output of one of these processing element has to be given to another processing element, which is going to carry out the second task that you have. So in this way, this is a chip with 16 such processing engines or processing elements. So 16 neurons operation can be done. Now once after that, let's say if you have more number of neurons that you have, after that, the same processing element has to take care of the operation of another neuron of another layer. This is a dedicated device where the activity which is to be performed by a neuron has to be carried out this. People may be working in weight management, in adjust management, in learning different kind of AI techniques. Ultimately, it's boiled down to a supporting system which can fastly do the weights and input operations. When you consider a deep neural network, it consists of hundreds of convolution layer and a fully collected layer at the end. And what are these convolutions? It is actually a summation operation. So it's a multiply and accumulate operation that you have x0 into w0 plus x1 into w1 and then finally adding the bias. So how you do? You need to have an input feature map and then you have convolution layers that is basically your filters and then we have an output feature map that you get. So if you look at any deep neural network, ultimately convolutions account for more than 90% of the overall computation. It dominates the runtime and energy consumption. Any neural network that you take, the activity that is being done is the convolution operation. Okay. So what is basically convolution? I am not going deeper into that. It involves multiplication and adding of each of these elements based upon a moving filter. Okay. So now consider, let's say you have three input vectors and based upon that you are going to have a weight matrix. Upon multiplication, you get the next element. Once you move the filter across, each time when you move the filter, one new value is being generated like this. So ultimately, you are producing one layer of the output vector. Then you move into the new row. and then essentially one by one that you complete. So this is one layer of output vector that you get. I hope this diagram is clear enough. So you are slowly generating values based upon an input vector matrix and based upon your weights or the filters that you apply. So one by one your values are generated. Now this in turn acts as the input to the next layer. And there you have a different set of weights. So when you talk about DNN computation, deep neural network computation, what happens is the layer values, whatever is the layer values, its weights has to be stored in a memory as an array. And then depending on your requirements, you have to move them from an off-chip memory into an accelerator circuit. Accelerator circuit is a special processor which has capabilities in performing convolution operations faster by having multiple parallel multipliers and adders. So you bring your inputs and weights into this global buffer, and each of these P's mimic the neurons. So appropriately, the values has to reach to all of them and then carry out it. Let me talk about it. Let us say you are going to make a feast, let's say food for 1,000 people. So you need to cut the vegetables. So imagine these are all, let's say there are 8 people who are specialized in cutting the vegetables. So I need to bring the vegetables from the shelf, wash it, and then appropriate. Let's say one is specialized in tomato cutting, one is specialized in brinjal cutting. So accordingly, there should be a mechanism which will feed into the brinjal in one place, the tomato to the second person. And once it is been chopped out, you have to bring it back. Then you have to mix and wash. Imagine this tomatoes and potatoes, everything is your inputs and weights. You need to have an underlying interconnection network through which there are a lot many people who has to supply these vegetables, the fresh washed vegetables, to those who are cutting them and then bringing it back. So if you have many such people, so the person who do this cutting, he don't know cooking, he know only to chop the vegetables. Imagine the thousands of them are arranged who know only matrix multiplication and adding and supplying them with a corresponding input. Such a kind of a circuit, a hardware circuit, is known as an accelerator. So accelerator is nothing like a super processor. Accelerator is a collection of multiple simple units, simple processing elements interconnected via an intelligent interconnection network, which will carry the data from a global buffer to the appropriate processing elements as and when the data is required. And once the result is produced, you bring it back. So what are the steps involved in processing of one layer? You bring the corresponding data from your off-chip memory, like your main memory or DRAM. You put it into the global buffer of accelerator. So NOC stands for network on chip. It's an interconnection mechanism which move your data from the global buffer into various processing elements. So your input feature map, the filters and the weights are going to move, process it, produce the output feature map, which is shown in blue color. Again, it travel through the interconnection network, reach the global buffer, and then maybe it will go to off-chip memory or it may act as input to the next layer. So this is the processing that is being done. Now let us try to understand how are you going to do the operation. Let us say I have a neural network whose input values and filters are already stored inside your main memory. And then you have a filter. So this is your accelerator, which has 16 functional units available. What you can see that 4 rows and 4 columns. I have to perform the task. So all the tasks are basically convolutions. So when you do something in software level, we never understand this much is the complication that is going in the underlying hardware. So we have a convolution operation to be done. So for that, we require somebody to do the task. So what is that? I can bring the input feature map into the chip, into the accelerator chip. So main memory is outside your chip. You bring it through the data bus and put it inside memory interface. Now you know you have to carry out this activity. Let's say your neural network has 6 layers in its or 6 neurons in its first layer. So I identify these are going to be my 6 units, processing units, which will carry out the operation associated with the first layer of the neural network. So now you have your input value available here, and these are the potential targets which are going to carry out the task. Now these input values and weights has to reach there. So I have to send them through this underlying interconnection mechanism as a small packet, so they will all reach there. Now every functional unit will have its own inputs and weights. And then what you do, you have to perform a convolution operation on the available weight that you have. And then ultimately, each of them will produce the result. And then it has to go further. So what will you do? You will send the result back into the memory interface, and then this memory interface is going to generate your output feature map. So when you talk about a neural network application, one layer of a neural network, a deep neural network, is being realized with the help of this. Some people work in the application layer where they write about new programs which will make use of neural network libraries. Some people build powerful systems which can run those kind of applications. So it is not like AI is only a program. AI wave is because we have programs together with powerful hardware that will facilitate execution of such program in a time-bound manner. So what is a neural network accelerator? When you have a specialized hardware consisting of many ALUs, and then you have a neural network whose operation has to be done quickly in such a kind of a hardware, then we call it as a neural network accelerator. This is exactly what I wanted to set the context on. Now, what are the different types of neural network accelerators? The first category is called data flow architectures, and second category is called architecture with in-memory technologies. Data flow architectures are of two types, temporal and spatial. I'll come to it. And then in-memory computing technologies are done with hybrid memory cubes and non-volatile resistive memories. Let me talk about data flow architectures. So now can you see that whatever processors that we have in our laptops, they are called temporal architectures, your conventional GPUs or CPUs, which has a central memory, and then there is a dedicated bus. So let's say there are many ALUs, you give to ALU, the ALU will give you the result back. You give the second input to the second ALU, so the result is going from the memory and the ALU will give it back. So it's temporal. You give the data. It is a single instruction, multiple data stream or multiple thread that we call it. But the output of one ALU cannot go to another ALU. That's what my requirement is. Output of one neuron has to go to another neuron. So ALUs are nothing but which are functional units where a neuron's activity is being carried out. Okay. Now, what do you call about spatial architectures? These are called FPGAs or ASICs, application-specific integrated circuits. It is a distributed control and memory. So what happens? Your ALU and your processing elements can talk. Can you see that ALU and ALU is connected? So you give an input and weight to one ALU, its output is being forwarded to the next ALU, only give the weights. So this will actually have a closer similarity. Your spatial architecture or data flow processing has a closer similarity with the kind of requirement that a neural network demands. So now let us talk about data flow architectures in specific. Now we know that there are three things that we want. We have weights, we have inputs, and we have outputs. So the first architecture is, let us put the weights in this. Let's say I have 8 processing elements, which I have numbered it as W0 to W7. So I'm keeping, let's say there is a weight value 0.25. Weight 1 is 0.5. 0.6, 0.01. Like that, let's say there are standard 8 weights. So I put the weights already stored. So it's just like a multiplier whose one of the input is fixed. And then what you do, you are going to give the input. So the inputs are nothing but it's coming in the blue color from the global buffer. Let's say the input value is go, you multiply with the weights. So you'll generate a sum that's going to the next one. So this is known as weight stationary architecture. Why it's weight stationary? Because I am keeping the weight stationary. I am asking my outputs and the partial sums and the inputs to move. I can also keep the input stationary and ask the weights to move. So this is called input stationary architecture. And the last one is known as both your inputs and weights are going to come. It is known as an output stationary architecture. Mostly the weight stationary architectures are being popular across accelerators that we see in the market. Now, whether whatever I am talking, is it fiction or is it really there? So this is something called an iris architecture. You can see from the reference. It is a specialized chip. We call it as an accelerator, which has such processing element. So the heart of such kind of any accelerator is a set of sequentially ordered row-wise and column-wise processing element array. So this 12 into 14 means 12 rows and 14 columns. We have some global buffers. So from the off-chip, when you wanted to run a neural network application, when you start fire or run, these values are taken from the chip, put into global buffer, and then you, with your interconnection mechanism, this is going to work. So what is this P? It's basically some scratchpad memory, some control unit, and a multiplier accumulator. This is a very popular accelerator known as iris architecture. Other one which is very popular is known as Simba architecture. So what you see a chip which consists of many such units. What is there inside that? You have a lot of processing elements and global array. And what is this processing element consists of? Many such MAC units that you have. So we have a Simba package. Inside that, we have a Simba chiplet, and then you have a Simba processing element. Some of you may feel that, okay, oh, why should I think about it? I am working in the software layer, so why should I want to know? It's always trying to understand a driver driving a car and a mechanic driving a car. So I am just trying to introduce you, even though you wanted to know only driving a car, you wanted to understand the internal structure of the engine and then at what acceleration you should run such that it's going to be very much fuel efficient, fuel economy. So this is known as the way in which the hardware support the existing applications. Now, think of a case that you have any kind of a data movement is costly. Let us consider if you are going to move a data from one ALU to another, let's say it's take 1 unit of time. Then if you move some data from a register to an ALU, same time. If you move from one processing element to ALU, maybe it takes double the time. When you move something from a buffer to an ALU, it takes 6 months time. When you move something from DRAM to ALU, it may take 200x times. So data movement is always costly. So here what we have seen that every accelerator consists of a set of processing elements which are nothing but ALUs or MAC units connected or supplied with a global buffer which will supply your data upon requirement. Data movement is a costly operation than an ALU operation. So what is the solution? Can you bring data as close as possible to something similar to that? Consider the same example that I wanted to do. You have a table. Now a table with a drawer where you keep all the important things. There is a pen stand. So these are things that you really want. Maybe if you consider your office table in your college, you have certain things that you put it on the table. So these are things that you require very common. What if you don't have any provision to keep it? You may keep it in a shelf or a common shelf or in a bag. So every time you want it, you are going and getting it. It will take a lot of time because data movement is costly. So can you bring the data close to where you do? That's why you have a drawer, you have a small shelf that is near to your table. So physically closer. Can you bring the computation closer? It can be done with the help of hybrid memory cube, or it can be done. Can you do the computation on the memory? This is called in-memory computing. In-memory computing is an evolving mechanism. Because we are not doing any complex operation, all these operations are mostly multiplication and addition. So when storage and processing is happening in the same place, your data movement is eliminated. It will save time and energy, and it's mostly an analog computation with help of some dedicated circuits. So what you wanted to do? You wanted to perform multiplication and an accumulation operation where data and weights get stored. So can I do the operation where data and weight is being stored rather than bringing data and weight to where processing happens? So our traditional concept of a processor sitting and the data operands are coming to the processor as if processor is the king, and then you go and go in front of the king and tell, can you please add it? That time is gone. Now the king has to go to where the data is and then just add it and then put it there. So the multiplication and addition operation is performed on a place where your data and weights are there. Let me look into this. This is something called a memristor crossbar. Can you look into the diagram? You're seeing a matrix kind of representation. Don't bother too much about what is this resistance all about. Imagine if you could store a potential, a value in the small component, what it looks like a resistor. So when you apply a voltage, it will pass through. What it does, it will multiply. So somebody who have learned already Kirchhoff's law, I'm not going deeper into it. This current that you get is nothing but V1 into G1. So this V1, it's a voltage that passes through the G1. V2 is another voltage that passes through G2. V3 will pass through G3. So it is actually a vector product of the voltage that is coming multiplied by the memristor value that is there. Now, can you correlate with what we have learned in your neural network? It's an input that is V1, V2, V3, V4 multiplied by a weight. The weight is represented as G11, G21, G31 like that. So once you train a neural network system, your weights are stabilized. Can you configure a circuit with some predefined resistance? Let's say this is 0.2, this is 0.5, this is 0.7, this is 1.5. So the input is converted to some voltage. So you have to move from a digital value into an analog value. They will pass through it, and then you produce I1. I1 is a current, I2 is another current, I3 is another current. So you are essentially generating a value. So this is what we need to do How do you do in-memory computing? Can I divide? So are you able to see that the way how the left side diagram and its equivalent circuit? Your inputs are represented as V1 and V2. Your weights are represented as G1 and G2. And the multiplication of them is already carried out. So my input are now not moving. My weight is already stationary. All what you need to is, if your weight is already known, you are going to configure a circuit which is known as a memristor circuit, where inputs are given and accordingly the values are being taken. And because of the serial summation of the current, it's just like adding. So can you see that this is a multiplication, second multiplication, and I'm adding. So the current here will represent exactly a MAC operation. So we have different layers of neural network. These layers of neural network can be represented with the help of a memristor circuit. So your weights are not moving. Can you see that? The weights are going to be stationary. Your inputs are also there. When the inputs simply pass through a circuit, this is at least 1,000 times faster than bringing your weights and inputs and getting it done in an ALU. So here there is no ALU. We completely eliminated ALU by virtue of the property of the circuit. We are able to mimic a multiplication. So what is this DAC? A digital input like a cat image or a dog image. You are converting that digital image into an analog signal, which is now coming through 4 of its inputs. When they pass it across, they will perform this MAC operation and then shifting. At last, you are going to put it under analog to digital converter. So effectively, it's a weight stationary data flow that we are trying to mimic. So it's an in-memory computing. What is memory? Storing of the resistance values. Okay, and then where am I doing the computation? Computation is done on memory. So based on this also, there are a lot many chips that has already come to the market. So many of our phones may have this. It's a memristor close bar based design, which will work on this. You can see that ideally all these tiles that you see, the tile consists of an ERAM buffer and an in-memory accelerator circuit, that's IMA that you saw, and each one of them consists of a crossbar. XB stands for your memristor crossbar. There is a digital to analog converter, and then ultimately we have an analog to digital converter. NeuroSIM is yet another chip where it has multiple tiles that is there inside a chip. What is there inside tile? It's processing element. What is inside each processing element? They are the synaptic array, which is nothing but a well-organized structure which will keep this. Another one, so there is a lot of research that has been happening. And this research, majority of the research is happening in US, little bit it's happening in Belgium, the rest in China and Taiwan. And India is now fastly picking up with the emerging semiconductor domain. Lot many AI chips we plan to do in the next 3 to 4 years. But we are facing acute shortage of manpower who are liking this. People all wanted to have AI ML workflow, but ultimately artificial intelligence, we require some systems to build. So with a lot of initiative push from the government of India to set up semiconductor plants, so already the effort is there, the foundation stone is laid. In another 1 or 2 years, you get chips from the Gujarat assembly plant and from the Guwahati assembly plant. So 2 of the places, and many state governments are coming forward. So at least it is a very promising domain to work on, because conventional microprocessors will get replaced with the AI processors. So what you see on the left side, you have many such tiles, and each of these tiles has smaller units. They consist of set of processing elements, and each of them consists. So it's a zoomed version, what you see. So this is your SIAM chip, what you see on the left side. It has a DRAM where your weights are being stored, and then you have accumulator and buffer. So this is called a network on a package. So it is very difficult sometimes to have thousands of processing units integrated inside a single chip. So what you do, we call it as a chiplet. We may have only, let's say, 100 of the chips here, and then this chip has another set of processing elements. So we call it as chiplets. So rather than it's sometimes fabrication of that much granularity of 1,000 microarchitectural units or 1,000 MAC units is challenging. So let's say have 100 each, and they internally communicate using a network on chip, but across chiplets you communicate using network of a package, and then you have processing elements, and then you have the crossbar switch. Now we are in the era where we have multiple neural network working together. I hope you might have seen about your Alexa or any other tool which will help you, which will recognize your sound and get your activity done. What is happening in an audio pipeline? The Alexa tool has to distinguish the keyword and then the speech. First is when you say that, no, this is an ATAL FDP So this is a word. So I have to detect the keywords. This is a word, is a word, ATAL is another word. So detect the keyword, and then you understand what is the context, what is the meaning of it. Speech recognition. So detecting keyword is one neural network. Speech recognition is another neural network. Both are working on the same hardware. This is known as multitask and multi-modal. We have hand tracking. At the same time, we have hand or shape posing. We have eye segmentation. We have gaze estimation, keyword detection. So there are a lot many category of neural network. These are called interaction neural network. You are trying to recognize your hand, segmenting your eye, gaze, detecting keyword, recognizing a speech in the context of understanding, semantic segmentation, object detection, action segmentation. Considering the word locking, you have depth estimation, so many things. What if I wanted to do two of them together or three of them together? Let's say you are going to have a gesture, opening a door with the help of your hand symbol. So the AI tool there or the AI system should recognize that your hand, first you are showing your hand, the face, everything. So first you have to understand where the hand is, and then you have to understand what the hand is showing. So hand detection is one neural network, hand tracking is another neural network. Now, I wanted to have an eye pipeline. So I talked about audio pipeline, hand pipeline, and eye pipeline. What is doing in eye pipeline? First, you have to recognize where is the eye in the face. This is known as eye segmentation. Second one, where is this eye tracking? So you have to look now where the eye has been moving. So think of a case when you wanted to do this real time. I wanted to, in future, let us say I wanted to take an attendance of a class. So there is a camera that is being fitted. The entire class is looking. So the camera is fitted on the top of the blackboard. So they'll take one sample or they're taking some video. So the system has to tell which all students are sleeping in the class, which are portionally listening. So now, if you are seriously listening, once in a while, now your eye will blink. So from the face of the student, first you have to identify eye. Second one, you have to track the eye. When are you blinking? So this is a neural network wherein two things are involved: eye segmentation and eye tracking. So what is the classification of this? This MTMM stands for multitask. You have to do multitasking, multimodal. Multiple tasks are to be done together. So it can be done like face detection plus face recognition. It can be done one after another. Then we call it as cascade mode. One model after another. So output of one model is given as input to the next. Or it can be concurrent model. What is concurrent model? You are doing them parallelly. So this is the new trend because your future thing is going to be 4 or 5 neural networks work together. Your sound, your face recognition, your speech, all has to be detected together. Okay, so from think of a case, future systems are going to be complex like that. So this is the way how it is going to. So you are going to design a robot. So the robot should have a navigation system. It has an obstacle detection. It has a segmentation, deep neural network. So multiple neural network working on the robot together, and it cannot wait for one after another. So you have to work together. So now look at see. I have a hardware. Now 4 of this color indicates 4 neural network. So among the available hardware, let's say I have 16 such chips. Now the weights of all the 4 neural network has to move. How do you do it? I can schedule all of them in all the 16 of them, and then you using a context switching, something that you have learned in a basic operating systems course. That's one. Or it can be spatial. Let's say I have 16. Out of the 9 of them I'm using for one neural network, the orange neural network, which is a little deeper. 3 of them given to the violet, 3 of them given to blue, and 1 is only given to this. And each one internally may have multiple processing elements or chips or something. This is a very recent work as it just published in this year. So this temporal multitasking and spatial multitasking is the way that has been forward. Now people started coming. When you have multiple neural network, why should I keep my chip uniform? Can I have a kitchen with some advanced cookery facilities and some normal cookery facilities? So for a simple curry, I may make use of that. If it is going to be a curry making for a larger crowd, I will make use of. So we have big chiplets, which are small functional units. We have little chiplets. So now it's called a big little chiplets. So inside a home, we have people, or let's say you are going for a cooking task, a mammoth cooking task for a marriage ceremony. There are some people which are capable of handling certain complex cooking. Okay, very, very sensitive cooking, the salt, the temperature, the adding of the masala, everything has to be very careful. Highly sophisticated cooks, which will do more important tasks, very complex tasks, and some less important cooks. So some of the items for the feast, for the dinner, is been prepared by this set of cooks, and the other little no smaller, let's say maybe a chutney or a sambar or a dal. The conventional one is prepared by the normal cooks. So we call them as little chiplets. Some of them we call it as big chiplets. So now I am telling you, tomorrow for the dinner, I have 20 dishes, and then this many cooks are available. Which dish will go to which cook? It's a scheduling problem. So when you have multiple neural network, which neural network will go where? That's the kind of tile architecture that we are talking about. It's like big little chiplets. So what is the future all about? The future is all about providing an optimized in-memory computing architecture for multitask, multimodal workloads. How do you do it? Optimize the design based on the number of neural networks that you have to do. It obviously depends upon the size of network and the intercommunication between the networks and what are the challenges. These are challenges which currently the architecture community is facing. We want some young minds or bright minds, whether if your students are interested. We have PhD programs here at IIT Systems, and we are working closely with many of the industries. These are all industry problems that we are working on. How do you group heterogeneous chiplets? So how do you size the network? How many chiplets you wanted to design? Don't consider that these are all electronic stuff. No, it's fully computer science only sometimes. So this is now, I have 4 big chiplet and then 9 small chiplets. So which neural network will run on the smaller one? Which will run on the bigger one? That's the way how it is one. So in short, when you talk about artificial neural networks and machine learning era, it's all about data. Huge amount of data is coming one after another. So we need to handle data well. Ensure that data does not overwhelm the components. How can you do that? Some of you may be attracted to algorithms writing programs. How can you do that? Why? By the help of intelligent algorithms. Or some of you are good in systems building, intelligent architectures and operating systems. Some of you wanted to work in the fusion of both. How can you do? You can do a whole system design with algorithm and architecture of devices. So what are data-centric architectures? Process data where it resides. How can you do that? By processing in and near the memory. Or can you talk about low latency and low energy data access? So that can be done with low latency memory. See, we have to bring lot many things from the memory. So if you're bringing lot many things in memory, you should talk about memories which are very low. And then what if you are going to work on a phone which is having a neural network accelerators? You need to have your phone whose battery will last till the end of the day. So the memory should be very much low energy consuming memory. How much is the cost involved in processing this data? High capacity memory at very low cost. You should have hybrid memory system, non-volatile memories. You should use compression. And sometimes where do you place the data? Which all should go to memory? Which all should go to cache? What kind of caching? So intelligent controllers which will handle this data with robustness, security, cost, and scaling. So the conclusion of my talk is machine learning applications will dominate future computing systems. Effective leverage of any AI or ML wave can be possible only with ML friendly hardware. So what is going to happen in future? So now after petroleum, the biggest money that we are spending is on consumer electronics import. If one fine day, if China decides, let's say we are not going to sell any of these chips to India, our roads should be filled with cars whose chips are damaged or not working. There is no service centers that is going to work. Many of our TVs, laptops, once it malfunctions, it's over. We are heavily dependent on some of them who are making chips. What if there is a clash in the border and then trade policy has been stopped? We can have it. Let's say we are not having a friendly relation with Pakistan due to one reason or other, and then we could still afford. But what if the same thing is happening with China or with Taiwan or with any other be a developed country where decide they don't sell chips to India? Then whatever AI ML wave that you have, ultimately your phone is malfunctioning and phone is not working. It requires servicing or replacement. We are in a deep mess. But thanks to the two for the last 10 to 15 years of good secretaries working in Ministry of Electronics and IT and visionary leaders, they understood this problem. We can become an independent country or superpower, digital superpower, only if we are able to have India's own systems that has been built here. Indians write beautiful softwares. thanks to our software companies which emerged in late 80s and 90s. I'm very happy to see that even if I visit some outside countries, when I go to a grocery shop or a bank, software by TCS, by Wipro or Infosys, this has been running in their banks, in their grocery shops as well. So this is something great. If Indians can write good softwares, we can build good systems also. What is the need? We need from our engineering colleges students who have a passion, not only for software writing, passion who can build systems, who understand this. So AI engines or ML processors will rule the future world. It's not the program that's going to rule, it's these powerful engines that rule the world. Can you just imagine if one day internet is a service that is provided by the United States? It's just started as a network from one building to another building in the military setup of US. Then it spread across states, across continents. So it's just a service. The format of the internet, the IP header, everything is being controlled by the internet community. What if one fine day if somebody wanted to switch off the internet? We are all dependent on it. So we should have our own systems where we are a self-reliant India. So what India needs to scale up manpower with passion and skill to contribute to build compute systems that augment AI growth. Everybody cannot go contribute to systems building. Systems building is slightly challenging, but if you feel you are good enough to take up such little challenges, then once in the next 4 or 5 years, when a lot of semiconductor plant is being set up, there is nothing like you need to know hardcore than electronics. It's all you write programs. We have tools which will take your programs into hardware. So everything is electronic design automation. So this is what I wanted to pass the message on to. So with this, I am concluding. I'll be happy to take questions if any. Over to you, the coordinators. I hope I have conveyed the message. I'll be happy. And this is uh, my mail ID. You can get to know more from this. We do run NPTEL courses on multi-core computer architecture during July to November time. Open to good students or faculty who wanted to work with us for internships. We are open for collaborations. If some of you wanted to work with IIT Guwahati, it's well connected. And then we have a 30-year-old IIT with close to 400 faculty and 9,000 students. We have a very good architecture group. We have a very good ML hardware group. We'll be happy to help you. So the new mantra is not like considering IITs as a tower of excellence, but then we want a network of excellence by joining hands with the teachers and students from other colleges in this country. So with this, I conclude. Over to you, the coordinators.
Thank you, sir. Thank you very much for the session. If there are any questions, please raise your hand. We'll unmute you to be there in the question for it. So meanwhile, others raise their concern, I have a question. Pertaining to AI, whenever, even in the previous sessions, whenever this question being raised regarding to AI, the first thing actually comes to the mind is about those algorithms and all those things. And pertaining to them, the support system, that what we actually discuss in this particular session, it is all about the hardware which actually sustain all these things. So how they actually complement in terms of these LLM models and all those things coming into the picture?
Yeah, it's a very good question. See, what you have to understand, it's all about without a specialized hardware, AI programs will take more time to run. I can still do it. So with the new set of AI applications coming, there is always a demand. Necessity is the mother of the invention. So now we have workloads, the large language models that has been coming. The kind of demand of data processing is too high that you require more innovation to be done on the systems level. That's why Intel, AMD, NVIDIA, all these companies have been doing. They're coming up with the new products. Do you feel that your phone get outdated quite fast when you have new applications coming? I feel 2 months. So the phones are all designed to work only for 2 months. They will release a new set of AI applications which make sure that you feel your phone is slow. You go to the market, your friends are telling, no, this phone is good. So you are in a vicious cycle. They first release the hardware, then they release the AI applications, which make sure your phone is slow. Then they come up with an offer, buyback offer. So you are in that vicious cycle. So this is something like a chicken and an egg problem. Which is faster? First, for some months, hardware is very powerful. When you buy a new phone, no, and then you feel, oh, everything is working good. Then every month you download new applications. After 6 months, you feel, oh, now my phone is slow. So 6 months, In a year, the hardware will be the winner. Next 6 months of the year, the software will tell, oh, no, my system is not that good. It's time to replace that. So this is going on. We need a lot many people to work on this. Our curriculum has to be revised. But the problem is with AI wave. So when I was teaching this C programming course at IIT, people are asking, sir, why do we remember all the syntax of these semicolon and everything? You write a program in ChatGPT, you give, ChatGPT will give the program. Then I ask, who will write ChatGPT? So if you look at the future of Indians who comes from engineering colleges, my feeling is 40% of them would be AI users. There will be some AI tool, I give it to them, it will give. 20% of, or 30 to 40% of them will write AI products. Okay, that's the next level. Some of them will write AI applications, new AI utilities, and the last category will do research on AI. So many places, research is utilization of AI libraries that is available. Give an image, train it, and then you tell that with my AI, I have done wonderful things. So it depends upon whether you are mere AI users or you are going to add up something, some small utilities into AI, make use of AI algorithms, or trying to do research in AI. That's where it's going to head on. Soon you will have the Ministry of AI, the way how Ministry of Electronics started. Maybe India is going to be the first country which may have an AI ministry. So future, 10 years down the line, some minister may come. I am the minister, cabinet minister for the artificial intelligence. Government understood it. That's why a lot of funding is being given. But we have to look into, based upon our capability, which AI layer I'm going to work on.
In the continuation, I mean, there is one more thing. I mean, particularly as you very much described that aspect, that 40% and 40% are actually looking into those software aspect and rather copying and getting results through those algorithms which are already being there by tweaking some parameters and all. But how we are actually making them understand that this concept starts from the base where this hardware is actually going to support those aspects. I mean, in curriculum also we are not having those things. I mean, we have almost 156 faculty member over here, and if we just talk about them, that how they motivate those students to do those things, I mean, they are not at all in the picture anywhere.
Thanks, Dr. Achal, for this question. In many places, in many colleges, what we discuss once the result come, pass percentage, right? Whenever the result come, everybody is making spreadsheet and making documents for accreditation. What is a pass percentage? We are always looking at making them pass. The pass is the criteria by which a teacher has been evaluated or a course has been evaluated. There can be 10% students, leave about IITs. Every college, there may be 10 students in a class of 60 who may be having the potential to look at into larger. So what he feel, he might have having a much more challenging class 11 and 12. When he came for an engineering program, he feel this is not challenging because I can study in 2 to 3 days just before the exam and I can manage. So as long as our questions and assignments are all pitched at a little lower level, then this is the way how it is going to be. And then students can work only on AI tools. They are all users of AI. So this will help if at least every teacher take a pledge that I will make sure there's 4 or 5 bright students in my class. I will give them little different assignments, little challenging assignments. I'll spend little time more of them so that some of them will have an interest in going for higher studies or R&D rather than merely looking for only an IT job. Look at what an IT job is paying, 30,000 rupees, 25,000 rupees. Some of our students are much more talented, but they are not aware about the opportunities that has been available. So at least if you feel that, if this out of this 155 people, how many of them will attend this program if Professor Ajal is not giving a certificate? Suppose if you tell now there is no certificate, there is a program like this, there is a 1 week program on AI, how many of them you will see? So that's exactly, that number will be 10%. Okay. So this is just like, what I talk in the Three Idiots movie. There are 3 category of people that you see. How many of them wanted to be real Amir Khan in our classes, in our course? How many of our students will come to attend a class on a Sunday when you take a special class on a topic, not in the syllabus, with no attendance? How many of our students will come? If you get 10, then you are a very good teacher. That's exactly what you wanted to try.
Totally agree with this. This is true fact. I mean, generally, even when we discuss these things with the student, they somewhere down the line they want to do it, but the system, I mean, peer pressure or the academic journey that is they actually foresee, that restrict somehow. But yes, I mean, given the opportunity, there would be certain number of students who would definitely go for it. They want to make a change. They want to learn those things in that particular manner. Definitely, it is going to help that way. Right,
So
sir.
we see there is somebody raised the hand. Can you please unmute so that he can speak?
Prashantji, you may ask the question.
Hello, good evening, sir.
Good evening.
Prashant Kulkarni. Actually, I liked your view that academics is lagging and AI is moving forward. But still, actually, I'm teaching in this JNTH Hyderabad. So what you are having academics, if you see the different trades like data science, artificial intelligence, computer science, EC. So strictly we are bifurcating these domains. That means a person who is in EC, he cannot go to AI. The person who is in AI, he is not coming to EC. Even I am working in communication, I only see AI, but how that is applicable to communication engineering, antenna design. So that we are unable to correlate due to our academic rules and regulations. So I think all universities and IITs, they have to suggest that if you want to go with the AI wave, our syllabus should be modified in that way. That is my suggestion. So
Thanks, sir. That's very good input. See, in a country with 140 crore people, what is government's first priority is to make sure they all go to schools. And then the very next priority, they get into college admissions. Now, nobody is stopping you from learning. With internet penetrating, lot many courses available. Nobody is stopping you from, there are lot many NPTEL courses. If you take 3 or 4 of them, one may be useful. I'm not telling all the courses are now will meet up your expectation. And then teachers like you should talk beyond the class hours. How many of us will be able to motivate our students uh, beyond the class hours? So that's why we will be able to get only 5 or 10. First of all, there is no need for this many engineers in this country. Number of engineering college seats are more than, so we are able to have students with a 40 or 50 mark also coming into our classes. No, because now we have increased the seats so many. So we are facing an acute talent in shortage of talent in some other sector. Conventional science and maths, nobody wanted to go. So this is a challenge. So teachers like you, if you can inspire, let's say 10 students from your college, go for a coffee with them, talk about the opportunities. You tell this course is good. Out of 10, if two get interested, then the purpose of this kind of MDP is served. You waiting here on this dinner time, I spending my time on dinner time, and every one of you, that's the way how we take it forward. We cannot change the entire class 60. We can only take 10. This 10 will tell, this sir is good, he has good ideas, he will spend after the college hours, tell to the juniors. So nowadays, everywhere, the seniors is the God. Seniors will tell juniors, whatever the teachers do, nobody will listen.
yes, sir, yes, sir. Thank you, sir.
Any other question? Any other participant who has any question? I mean, so I guess we need to thank sir because I mean it was indeed altogether very different session than what we had. I mean for last 4 days, and it ignites something from the faculty fraternity who can think beyond that academics and everything. Uh, Thank you, sir. Thank you very much.
Thank you.
Thank you, Professor Jose, for your enlightening session. Your expertise has shed light on the groundbreaking advancements in computer architecture for AI and ML. So, with this, we conclude day 5 of Faculty Development Program. We sincerely thank all our attendees for their engagement and enthusiasm. We look forward to seeing you tomorrow for the concluding day, which promises even more inspiring discussions and learning opportunities. Have a great evening.
Just a reminder for tomorrow, we have session starting from 2 p.m. So please be on time. Thank you.
Hello, sir. Hello.
Yes.
Sir, there are any kind of the quiz tomorrow, or they have only the session because in the from 2 onward I have a class.
If there would be a quiz, I mean, it would be only after the 3 sessions. So we
Okay.
need to see, I mean, if we can set up the timing for quiz tomorrow, we will definitely do it tomorrow. Otherwise, there is an option. We can give the timing at which you can attempt that quiz.
Okay. Okay. Thank you, sir.
Thank you. Yes. Bridget. Okay, you may ask the question.
So, am I audible now?
Yes, 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 please.
Yeah. Sir, could you please clarify what is the attendance process? Because I have been attended all the session and attendance has not been granted for me for last 2 days. And I see a lot of conversation going on in the group. Could you please clarify that?
Sir, what we do, I mean, it is automatically being downloaded from the Teams itself. So we just need to verify, I mean, the names which are already being registered. Otherwise, I mean, those who have join this particular session through the email ID which they have registered, it becomes very easy to mark the attendance. For those who actually being shown as an external or unverified user, we need to map it with the names and then accordingly we need to assign the attendance. So in case any issue, just tag it out because the team is looking into it and they are providing if there is any discrepancy in the attendance, they mark the attendance.
Okay, sir. Thank you.
Thank you.
Hello.
Yeah.
Yeah, actually, when I am trying to my laptop, it is going to another email ID. That is, I attended all classes, but my email ID is different from registered email ID. What I can do?
It might be because you have the institutional ID through which you actually logged into the system. So if you are giving your name as what you have mentioned, so we will try to map it and provide that attendance.
Okay, thank you, sir. Thank you, sir.
Thank you.
Hello, sir.
Yes, ma'am.
Sir, how we can get the materials from all the speaker?
I have already shared those PPTs in the chat group because I was trying to upload it on the portal, but there are certain constraints they are showing it. I mean, it cannot be more than 5 MB and all those constraints. So before we actually get through it, I mean, I have shared it in the group, WhatsApp group.
Sir, in WhatsApp group, you have already shared.
Oh, shoot. I didn't get it. Please repeat.
Sir, I have not received that.
WhatsApp group link.
Okay, sir. Okay, sir.
Well, I can share the link. I mean, here also. I mean, if you wish to have, just give me a second. I will share it here in the group.
Yes, sir. Please
Yes, yes. Just give me a second. I will do that.
Hello, sir. Good evening.
Good evening, sir.
Sir, yesterday admins need not upload, sir. For yesterday admins.
Yesterday attendance. I mean, it is to be uploaded today.
Okay, sir. Okay, sir. Sir, tomorrow we have only quiz sessions. That's
No,
all.
we
Please.
have 3 sessions tomorrow.
Okay, sir.
Yes, it's starting at 2 p.m.
2 p.m.
Professor DP Vidyarthi from JNU will be taking first lecture. Then
Okay, sir.
Pankaj Sharma will be taking the second lecture, and myself will be taking the third lecture.
Okay, sir. Okay, sir.
Thank you.
Okay, sir. Thank you.
Thank you.
Yes. Ja, dann reinigen wir die Lagen ja. Und ist das alleine?
Then again, there would be a problem. Chat is not open for all. Only guest can see it. Mhm.
मम्मी कल के लिए आप जंक फूड बना दो
क्या
फ्राइज
चावल बना दो येलो
नहीं मम्मी
क्या बना
क्वेश्चन का क्या होगा? क्वेश्चन तो है नहीं फिर भी।
जम्मू कश्मीर के सामने
दोन्ही कापले
Those who are not in the WhatsApp group, they may take the QR code. It would be easy for them to be added into the group. Thank you.